Happy Monday! Today we're going to talk about percent composition. Percent composition is fairly straightforward. It's the composition, or it's the percent by mass of each element in one compound. So we can think about compounds kind of like a pie chart. If we have a hydrocarbon, mostly made up of hydrogen and carbon, looking at the compound as if it were the pie, and then we can split it up into its parts. The larger one probably being carbon, and the smaller one more likely being hydrogen. These parts of the pie chart are percentages out of 100. Percent composition tells us about this. It's used it's used largely in forensics in order to identify difference in substances. We can use our percent composition to come up with our chemical formula. We're going to talk about how to do that tomorrow. In order to find our percent composition, we simply put the mass of the element over the mass of the compound. And then multiply by 100 to get a percentage. This is the formula you'll usually see. However, we have to make a different equation for each element that we're looking at. So we will have one of these made for carbon and one made for hydrogen. Let's look at an example. When a 13.60 gram sample of a compound containing only magnesium and oxygen decomposes, 5.40 grams of oxygen is obtained. What is the percent composition? In this example, we are given our total mass here and the mass of oxygen here. Using this information, we can go ahead and create our equation for our oxygen, putting the mass of oxygen, 5.40 grams, over the mass of magnesium, 13.60 grams. I'm sorry, this is our compound, not magnesium. When we do this division, the number that we will get is going to be 0.397. Note that our units here cancel out, so this number will not have units. We then multiply by 100 in order to get 39.7% oxygen. However, this only gives us the percent composition of oxygen in our sample, not the percent composition of magnesium, which we also need. This problem does not give us a mass of magnesium, therefore we have to figure it out. We have enough information here to do that. We simply take our total amount, 13.60 grams, and subtract the amount we know belongs to oxygen. The leftover or remaining amount, which should be 8.20 grams, will be all magnesium, since magnesium and oxygen are the only two elements in this compound. From here, we simply take our 8.20 grams of magnesium and put it over the 13.60 grams, which is our total. Again, grams cancel out, which will give us just the number, being 0.603. We multiply this by 100 to get the percentage 60.3% magnesium. Now that we have the percent composition for each element in our sample, we have finished our problem. If these numbers don't look right to you, you can always double check by adding them together. Since they are percentages, they should add up to equal 100. In this example, this adds up to 100. Let's look at those steps one more time. First, we were not given the mass for magnesium, so we had to calculate it by subtracting the mass of oxygen from the total mass given. After this, we divided the mass of each element by the total mass of the compound. This gave us a decimal. We multiplied that decimal by 100 to get the percent. All right, if you're ready for a second example, we're going to move on. If not, you can go back and re-watch that first example. Our second example says a compound is formed when 9.03 grams of magnesium combines completely with 3.48 grams of nitrogen. What is the percent composition of this compound? Pause the video here and try to work this out. All right, the first thing we need to do is identify what our numbers are showing us. We're given how many grams of magnesium and how many grams of nitrogen, but we are not given our total mass. For this situation, all we have to do is add our grams of magnesium to our grams of nitrogen to get our total mass. So 9.03 grams plus 3.48 grams should give us 12.51 grams. This will be our total amount. If you had trouble with that, you can pause the video again and try to work it from here. From this point, we're going to set up our equations. So the 9.03 grams for magnesium over the 12.51 grams, which is total. Remember, grams cancel out, and this will give us a decimal of 0.722. We multiply this by 100 in order to get 72.2%. This is for the element magnesium. Then we take our 3.48 grams of nitrogen and put it over our total. Grams again cancel out. This gives us the decimal 0.278. Multiplying that by 100, we will get 27.8% nitrogen in this sample. Reviewing those steps again, this time we added the masses of our elements together in order to find the total mass of the compound. After we had our total mass and each of our individual elements' masses, we were able to follow the same steps as in example 1. All right, this is example number 3. In this example, we can calculate percent composition from a molecular formula. So we're going to walk through how to do this with propane. Propane is C3H8. In this case, we have to use the molar mass of propane as our total mass. The molar mass of propane is 44.094 grams per mole. We then divide the mass of each element by the molar mass of the compound. But first, we have to find the mass of each element. For this, we are going to use their respective masses. 3 carbons equal a molar mass of 36.03 grams per mole. 8 hydrogens equal 8.064 grams per mole. From this point, we work the problem just like we have in the previous examples. Go ahead, pause the video, and do that. All right, let's check the answers that we got. Starting with carbon, 36.03 grams of carbon over the total 44.094 grams, which is our total for propane, should give us 0.817. Remember, grams cancel out. We multiply this by 100, and we find 81.7% carbon. For hydrogen, we will have 8.064 grams over the 44.094 grams. Grams again cancel out, and these numbers should give us a decimal of 0.183. We multiply this by 100 to get 18.3% hydrogen. Again, if you're not sure that your percent composition looks right, you can always add these together to make sure they add up to 100%. Looking over the steps. In this example, since we are given the molecular formula instead of our mass amounts, we used molar mass of propane as the total mass of the compound. We divided the mass of each element by the molar mass of the compound. Remember, we got the mass of each element from the parts of that molar mass of the total propane. Lastly, we multiplied by 100 to get our percentage.